Hello and welcome. I'm Katherine, a staff writer here with GovCIO Media and Research, and I'm moderating our panel on storage and compute strategies to unlock data. Today we are joined by Paul Puckett, U.S. Army Director for the Enterprise Cloud Management Agency, Frank Indiviglio, NOAA CTO and Deputy Director for High Performance Computing and Communications, Ben Brown, Department of Energy Director of the Facilities Division for Advanced Scientific Computing Research, and Kurt Steege, CTO for ThunderCat Technology. Thank you all so much for joining us here today. To kick us off, I want to begin by talking about data management. When it comes to data management, it all starts with knowing what you have and mapping business processes for securely sharing that information. Paul, I was hoping you could start us off by telling us what are some of your strategies and best practices for creating efficient data workflows at U.S. Army?
Thanks for the question, Katherine, and thanks for having me as well. So a few things for context. In the United States Army, I run the Enterprise Cloud Management Agency, and our vision is to accelerate data-driven decisions at the speed of operational relevance. And the whole entire point there is when we talk about the adoption of cloud computing as really a catalyst for digital transformation, we're really getting into conversations of our ability to see and use our data in real time to support the mission of the United States Army. But part of the challenge when people talk about the security cloud and when people talk about essentially architectural considerations, when you think of public cloud versus private cloud and where capabilities need to reside, truly you need to understand what data you have and what mission objectives you're trying to achieve. And to that point, when we think about how systems share information or how oftentimes we find in the Department of Defense that people are really the interfaces between systems, we really need to unpack really the workflows that we have and how we're actually moving data, and whether that is a machine interface or whether that's a human in the loop. But really, we have to map that end-to-end business process. And so when you start to talk about business process mapping and you start to see the interfaces, human or machine, between systems, and you start to see the manipulations of data, or quite frankly, the duplication of data, you can start to see where error and toil is introduced into the process. But more importantly, you can start to see where security starts to break down and governance starts to get lost. And therefore, our ability to see and understand perhaps two different data sets that have context with each other now becomes a really cumbersome thing to do. And so back in 2019, the Army put out a data and cloud execution order. But at its core, it really said, we need to start to map how we move data, what data is authoritative, what data is duplicative, and we need to start to see the systems that are now responsible for the brokering of this data. And we need to start to modernize ourselves so we can eliminate duplication of data and optimize our business processes and our workflows. And just a simple example there are a lot of our workflows that are duplicating and disseminating data worldwide. But we come to find that all the different endpoints happen to just simply be running a simple standardized algorithm and analytic against the data to get to some outcome. And so when we think of the opportunity with on-demand compute and storage like cloud computing has for us, why wouldn't we simply tweak that workflow, run that analytic with the abundance of computing resources we have in the cloud, and simply disseminate the result of that analytic, and then even leverage machine learning or even artificial intelligence to see perhaps what opportunity might reside at the other end of the unknown algorithm that we have yet to build. So that there's a wonderful world that we can reimagine, but it first starts with really mapping what that business process is today, and then seeing where you find toil within that process and some opportunity and ways that cloud computing can help you on that modernization journey to simplify and access and use your data for the speed of operational relevance.
I think that's key, Paul. And you know, I kind of said a few times in some other discussions around, like, I think information and data safety and its sharing is a key product, not a byproduct of the government, and how we move forward, you know, with, you know, I think you mentioned it perfectly in terms of, you know, visibility, stewardship of that data, understanding the why behind that data, and then you start to go through the next process. And I know we're going to talk a little bit more throughout the panel about like eliminating these data and workflow silos, preparing for the future, and shifting the culture towards a data-centric culture as opposed to an application-centric culture. And I think that's what you're dealing with right now.
And the science domain. Oh, was just thinking about, Paul, your remarks are so resonant in our world and in the open science community across the nation. It's sort of through the looking glass, but the themes are the same. So you have all these researchers who have a lot of homebrew solutions, and even the culture of science being about sharing and open inquiry. So much of what you said resonates so deeply because it's about the sociological barriers to adoption, right? Or just surfacing shared insights and in the context where people are receptive to the ideas.
That's absolutely true, Ben. And I'd even add a lot of the apprehension when we talk about the security of the cloud that I've seen in practice is more so people that actually don't understand what data they have in the first place. And how can you secure something if you don't understand the criticality or sensitivity or just the mission need of the data? So a lot of it starts with understanding that to truly understand how you design controls within any environment, public or private.
Yeah, just to add to that, I think that, you're talking about workflows and how things are put together. I think that data management piece has to be, that's the important part of kind of looking through that workflow process, right? The data management has to be ingrained in part of that workflow. Thinking from a climate perspective, right? We're moving a lot of data, generating a lot of data, and if you don't manage that, you may not lose results, but you may misplace results. You'll have to rerun jobs or just you intensify the work for the user if you don't have that kind of management ingrained in that workflow. So it's got to be from the start to finish, right? You have to kind of ingrain that in the culture.
Absolutely. And I think that sort of sociological question might be a big theme in this conversation. But I think this is interesting to discuss, coordinating away from that duplication of data and really ensuring that security. Let's see. Next, Frank, I'd like to turn to you. I'm hoping you can tell us a little bit about high performance computing and what does high performance computing unlock and what sorts of problems or questions is your organization addressing with HPC?
So that's a great question. Thank you. It's a big HPC for us is kind of the crossroads where a lot of the science that we do and the products that we produce comes together, right? So if you take a look at a forecast day, right, there are 3.5 billion observations that go into a forecast on a day-to-day basis, right? That's a lot of data that gets put together, and out of that data comes a number of products that span a number of timescales, right? From the minutes, right? Think tornado warnings or storm warnings, flash flood warnings, all the way out to multi-decadal, climate change, climate impact changes. So a lot of that is driven from in the modeling community and the observation community through HPC. So we have a very large mission space. It's from the surface of the sun to the bottom of the ocean, and the products span all of that from space weather to ocean conditions. So it drives a lot of not only the data ingest, but the data production. If you take a look at a climate workflow, they generate somewhere between 5 and 10 terabytes an hour just of data that's going to be processed and grow 4 times to get the real insights that folks need to monitor climate impacts or weather impacts. So it is a large driver. It's a big data producer. It is also, going back to our last question, it is a great introducer of complexity into a workflow, right? There are a lot of parts, there are a lot of moving parts in an HPC workflow with an HPC system, and you have to again be cognizant of how things move through that system and how the data is produced, where it's going. From a scientific perspective, and that's the way we try to treat high performance computing within NOAA, right? It's a scientific instrument, less a computer, more a scientific instrument. How do we manage all that and make sure that we're getting the answers that we expect, that we need, right? We depend heavily on the right answers, right? So there's a lot of that data management workflow and movement of data through that system has to be checked and verified to make sure that we are getting the answers. The computer behaved the way we expected, the data came out the way we expected, and you tend to trust your equipment, but you do have to verify it. We're talking 15th decimal point kind of checking just to make sure that we that has a very, the butterfly effect in a model can can be very detrimental to results. So, and also the data movement, you want to make sure that your data movement is that you're trusting your tools, but you're verifying. We have not run across a tool where we haven't found a transfer issue, and that will introduce issues later. So a lot of the verification and checking has to be built into that workflow around the HPC system. So it becomes a complex thing.
Beyond the HPC thing, and this is probably something I was going to talk about a little bit later, but I think it makes sense based on the context of what you just said, and kind of what Ben said earlier in terms of these partnerships and this sharing of information. I mean, things like, and we're driving technology just beyond the data, driving technology, things like ForecastNet, which was Lawrence Berkeley National Labs from Department of Energy, Purdue, University of Michigan, and Rice working together to use AI in terms of building out these atmospheric rivers. And then you've got the other piece of it from the industry side, and NVIDIA talking about digital twins and Earth 2. And I'm just curious how that's kind of changing the way that you guys might be doing things at NOAA.
Well, that's an interesting question, and I think there's a couple different viewpoints, right? You know, especially on the digital twin side, there are some who will argue that digital twin is a model by a different name, right? Which can depend. But I think it will. There are certainly things that will change it, right? The introduction of things like AI, right? So weather modeling has traditionally been a very deterministic process, right? It's math. We do the equations, we get the answer. There is a lot of potential on the probabilistic side, right? Which we already do, right? You can see it for large, high resolution models. They use probabilistic determination to kind of get a handle.
The idea of deterministic. You said descriptive, and the idea of inferential, and where you can go with that.
Yeah, so I think it has a great potential to change things, and on not only a gain efficiency, right? I'll get a lot of compute back because I'm going to reduce my compute impact by doing more data processing, but it also gives us more insights, right? You can get a lot. I know there's some interesting work on super local forecasting on the probabilistic side. There's also a lot of benefit of getting a better understanding of parameterization for large, high resolution, like hurricane events, things like that. So there is certainly a lot of upside. And it's interesting from a technical perspective to kind of see that from a data side, because they don't behave the same way, right? Large data flows from models and AI streams don't behave the same way.
Ben, I'm wondering if you would like to add anything about sort of managing some of the complexity in workflows that HPC can introduce.
It's extreme. I mean, obviously in the Department of Energy, we work really closely with NOAA and other agencies on the next generation of supercomputing. I'm really proud that recently we rolled out Frontier, that's now #1 in the top 500, but it's not just about chest thumping with the stats. It's really about, for us, the science applications and the R&D applications, not just for DOE, but other agencies and critical needs for the nation. And what we see is, you go back to that workflow terminology, it's not just that we're pushing the frontiers with the computing hardware, and that has follow-on huge challenges for the software that has to move along with it. And oh, by the way, talk to any given scientist or an application lead, that's a really tough conversation about buying down risk. Who holds the risk for rewriting the code, right, to get GPU ready or AI ready? And then all the way on the other end of the spectrum, contending with the flow of data in and out of the machine to your local storage across the wide area network to another research institution around the country. So our research infrastructure, we're very proud that we have the expertise in the DOE National Lab system to contend with the extreme scale of data. But I think the thing that's a hallmark of this moment is that we're sort of being hit in the face in all directions with the flux and volume and velocity of data sources and the rich new variety of use cases that are kind of popping up and saying, ooh, we want to use high performance computing. We have an urgent need, and we can't say no to that, of course, but we are limited in our resources. So it's a lot about partnership and looking for ways to grow an ecosystem model, really. That's really what we're focused on right now.
So Ben, I've got a question for you then. When it comes to that backlog of people requesting access for high performance computing, And with the commercial cloud companies trying to take some of that market, right, with bringing some of those capabilities online and in more commodity resources in the cloud, how do you make that investment determination of what resources get after what problem you guys are trying to solve? Where's the line that you draw for who gets access to that very, very precious resource of HPC?
This is a critical question for the nation, honestly. And there's a lot of attention in the interagency, as I know you all know, about, especially AI is sort of a watchword. It's prompting this question, but it's really a deep-rooted question about, do we have the capacity for the nation, for the R&D needs? Some of these questions get answered organically without any sort of top-down direction by just, are the codes ready? Are the communities, do they have their codes ready to migrate? That's not a really satisfying answer for those who aren't ready. So what's on our, we in the Department of Energy have a research portfolio where we have investments where we work with communities to get those codes ready over timescale of years. And it's very challenging because we have great examples. I don't want to name names where it's gone swimmingly, where there's sort of a resonance and the partnership flourishes. There are others where there's actually skepticism of, well, will we be there to provide sort of the core of the software ecosystem? So with a movement to the exascale regime, we've invested probably one of the largest software development projects ever undertaken in the Department of Energy, the exascale computing project, to at least tend to well-vetted set of about 20 core applications that span open R&D, national security, clean energy, other core Department of Energy equities, and other agency equities. But it's one of those classic, there's no easy answer, and I know you all know that, but it's truly the struggle of the moment, especially was alluded to with computing hardware in this incredibly rich evolutionary period, the Cambrian explosion, as some call it.
And I think an important point in that, just to add on to what you're saying, and kind of a different facet of the question, Paul, is the determination. I don't think there is an organic answer, but how you incubate people to grow, to scale, however you want to call it. I think that's an important aspect that it may be overlooked in our kind of day-to-day operations, but you have to have programs, or at least think about setting up programs where you can incubate folks to grow, so they can explore, right? Whether it be a traditional HPC system in the cloud, whatever that is, right? Our job is to find the right architecture and the right way to get their jobs done, right? So how do we introduce people to tools and techniques that we have? And there's a number of ways you can do it. I don't know if there's a right way, right? We have incubator programs in NOAA to kind of get people in front of technology. We do hackathons and all kinds of other good things. But I think that's part of the challenge is not only finding the right solution, but it's also kind of fostering an environment for people with real good science ideas to kind of grow up into a bigger ecosystem.
I'll just add very briefly.
It's interesting. There's been stuff there. Sorry, go ahead, Ben.
Very, very quickly, I think I jumped over Paul's root question maybe too, which what's our relationship with cloud vendors? And we want our communities, our researchers, to be able to fluidly go back and forth between our resources and them, and we're not there yet. I think that if we were to achieve that in the next 5 to 10 years, that would be incredibly powerful. Sorry, Kurt.
My point I was going to make was sort of some of those things are driving each other back and forth on the collaborative side. There's been full supercomputers put into the cloud, into Azure specifically in some areas. There's been dealing with the forces around what you can do with it, AI, and on sometimes a smaller scale. But then at the same point, it's driving some of the innovation on the technology side, on the commercial side. With folks like NVIDIA merging chips together, where you be able to overlay CPUs with GPUs and even new forms of chips. The Loihi thing from Intel, where you're talking about streaming, or GraphCore dealing with graph analytics, designing specific chipsets just for that.
Yeah, you're all hitting what I was poking at. For instance, Army Research Laboratory, main leader of HPC for the United States Army. Part of our partnership with our organization with them is, as that line is constantly redrawn between commodity and commercial resources, is to have them at the center of where's the greatest opportunity for what I'm trying to learn, because it is such a precious commodity on premise. And from a cultural perspective, the research and development community, I believe, naturally leans in to be data driven, but on the operational side, for more so the customer just simply consuming a capability, it's not ingrained because it's just the thing that they were given. But now as we see this migration to cloud computing, there's this challenge of how do I start to learn from my data? And then therefore, what's the right capability and resource to learn at the right rate, given where I am in maturity, but also what some opportunity kind of sits out there. And Ben, to your point, is investing in those places where it may not be the one that's ready, but it's the greatest opportunity for the mission to learn from is really a critical investment I think many overlook.
I think pivoting a little bit away from compute, but now into the topic of storage, I know the volume and velocity of data production across government has grown to a point that we haven't seen previously. So I'm curious how you all would say this has changed the landscape of data management, particularly when it comes to storage and movement. Ben, could you start us off?
Yeah, just briefly, I think fundamentally in two things. It costs in a way it never did before, because in a lot of our cases, it was sort of an afterthought or sort of bring your own storage if it's an application, notwithstanding obviously the data center context. I'm talking more about the end-to-end workflow, but something more fundamental, and going back to that sociological theme, there's something really powerful going on with, we used to have a practice for many years of, okay, we're building the next supercomputer. We would come to each sort of scientific community and ask, what could this tool do for you? And separately in our wide area network, we'd come with a separate conversation and say, well, we're going to build the next generation network upgrade. What do you need? These conversations can no longer be separate. Because of the workflows, and this is a good news thing. I mean, more and more people are becoming aware to the tools as we surface in this conversation. That means that we're having to completely re-architect not just the kind of the conversational circle and who's in it, in terms of the whole spectrum of end-to-end issues, but also the cadence and tempo with which we engage. So it used to be once every 3-4 years we might go to, say, the material science community and ask what their needs are. Now it's much higher tempo, and we're rewiring things to be more of an annual cadence at a minimum for understanding user requirements.
Yeah, I think the bit that you brought in there and the bit that we've kind of touched on throughout is this sort of shifting the culture here, and I think that's what's driving all this stuff. It's not, I mean, I know we're talking a little bit about technology, we're talking about this and that, but it's the information, that information that was taught, you had those discussions, you had those ideas about what to do from a technology perspective, and the data was sort of, hey, we'll just move the data to that technology. Now the data is growing so fast and building so quickly that we have to shift this culture to this, away from this, and drive towards data-centric ideas. I mean, I know some of the work that we've done discussing with the DoD and, some probably folks that feed into you, Paul, fit that space. We're talking about, sensors on I know you're Army, but, sensors on soldiers out there, sensors out on planes and things like that, and feeding all that in, using some of the same techniques in terms of modeling that are out there. I mean, I know there's a lot of collaboration even between the energy folks and the NOAA folks, but even between the folks on the DoD side. We worked on a cluster talking about WARF with some folks on the Air Force side. So a lot of this stuff kind of bleeds back and forth in terms of there, and I think both sides are leading that space. All the different mission side.
Just to add a few points, when it comes to the volume of data, obviously immense, but our opportunity to actually understand that data is really important. That there's compute right there with the storage opportunity. There's so much data that they take in and just sits dormant, waiting for someone to learn something from it. But historically, within the United States Army, a majority of our systems in the tactical domains have been deployed to execute a mission. But very few were ever designed to capture that data so we can learn from how operational missions were conducted. And oftentimes we find that the data that we really want is sitting between somebody's ears. It's a decision that a human made that we have no way of actually capturing and understanding what that calculus was, if you will. And so a lot of our initiatives now with adopting cloud computing is taking those same systems, but starting to build in the ability to learn from the ecosystem as we conduct missions, so that we can actually run, experimentations off of real operational missions that we saw, because we're using real data And just that opportunity to be able to capture real data and then to be able to learn from it is fundamentally changing a lot of the TTPs within the Army for how we conduct exercises. And so I think there's just an immense ability to learn now that we've got this data. But again, being thoughtful of what resources you use at what point in time, what you're trying to learn is really critical. And more so, we're seeing that evident in cyber protection as we start to aggregate information from sensors that exist everywhere within our network. How do we truly defend within a zero trust architecture? And that is an immense challenge, but is a great opportunity for where we see our cyber leaning in there, and just what they're learning from initiatives like Gabriel Nimbus that's facilitating the aggregation of this data and the analytics to truly be able to defend, but also potentially even predict where we might see vulnerabilities and remediate them before there's ever an issue.
And so, Paul, you mentioned the word transformative, and it brought something to mind. I think it's an important part of this, right? The way we collect data, like you talk about sensors, and that's something that we do here at NOAA too, right? It's how you treat that data. Normally take an observation, it gets archived and processed, whatever. However, that process looks like now, we have the ability to do things at the observation point or at the collection point that we couldn't do, several years ago. So how does that stretch your workflow out? How does that stretch your processing out? And more importantly, what does it do? Going back to your insights, right? How does it help your scientists or your end users, right? The better we can process data at, not to use a buzzword, but at the edge or at that collection point, the better, the quicker I can process it through, and then the later in the forecast chain I can introduce it, which means I get a better forecast result at the end. So I think we have a lot of opportunity in the whole data path of kind of not just to production, not just to management, but really to introduce some transformative ideas and techniques to improve our overall mission.
We've touched on throughout this conversation the role that sociology or culture or partnership plays in this data management. And so now I'm curious if we can discuss how at the moment there is currently sort of a push across government to build more of an ecosystem model for data sharing and collaboration. But there are also challenges in technology and policy and sociological challenges to arriving at that coordinated environment. So I'm hoping we can dive a little bit into that cultural question and what that looks like across your different mission spaces, whether you're working with interagency people, internal agency stakeholders, public-private partnerships, academia, and all of those partnerships. Ben, could you start us off?
Certainly, and it really resonates with so much of this conversation. In terms of that convening power that we have on the Fed side, which is a very significant privilege we have of drawing our stakeholders together on a cadence that works for our strategic planning processes. One of the things we're really focused on is really tending to the fact that this is change leadership, and that the only way that the message is completely bilateral is that the conversations are actually small enough. With such large strategy questions, it might be natural to sort of convene a very large group, a huge number of stakeholders or a variety of things. And of course, we do occasionally, but we're finding that the highest value traction and the best way that we can be good listeners is it's long and hard work, but it's to sort of chunk out the opportunity space by stakeholder group, and also to create cross-cutting spaces where we're bringing people who haven't met before together to share their insights. When we're in that learning mode, we're finding that that's the most powerful way to advance the ball in terms of us getting not only insight we need to do that fuels our strategic planning and budgeting, but frankly, in terms of that, culture change it's a cliche. We hear it all the time, especially in sports. Culture it just is. And so we know that we have to be attendant to it. We have to vocalize it, verbalize it. And I know that sounds like maybe a lot of more MBA type speak or management speak than technical speak, but that's really what we're engaged in right now.
But if we just take a step back for a brief moment, the intelligence community learned a really hard lesson coming out of the 9/11 Commission. When it came to, we had all of the information, it just came to legal barriers and information sharing across the agencies when it came to potentially preventing those attacks. And so if we look at just across the federal government as a whole, just simply our ability to be able to discover data, right? Our ability to be able to say, this is what I have, this is the potential opportunity here, is really critical. It's why I believe so strongly in what the Deputy Secretary of Defense Hicks put out when she had her data decrees, is talking about our ability to get after data that is vaultist, in the sense of visible, accessible, understandable, linked, trusted, interoperable, and secure. And that linked is kind of a tweak on the typical VAUTIS acronym that people would lean into. And our ability to remove humans and start to see how systems can start to share information directly is just so critical. And so I'm very thankful for those initiatives. And part of those challenges, again, is people understanding what data they have, but more so incentivizing the behaviors to share data that may show a little bit of I'll say, debt or even error. Part of the culture that we've created is no one, being wrong. And we really start to see that just being completely dismantled. And you now have senior leadership in the DoD as well as the Army with Dr. Iyer and Dr. Markwood simply saying, let's get to information sharing and let's work out how we start to understand and use this data in an appropriate way. But first, we have to expose access to those systems. You can see it in our cloud plan for 2022, called out even explicitly as part of our level of effort when it comes to data and information sharing is leveraging more machine interfaces to exchange and to really expose access to data. And then therefore designing systems in a way to facilitate both either real time or as well as the support for a more longer term analytic process and visualization for how we can learn from our data in a more kind of forensics manner, if you will. So I'm very thankful for those movements. There's a lot of work to be done, but the hope, dream, desire is we do not have to learn a hard lesson, much like the intelligence community did. And thankfully, you see leadership leaning in before there's some catastrophic event that just simply shows us that we should have put more of a priority on this. And I see that priority today, and for that, I'm extremely thankful.
And so I look at it a little differently. I mean, similar to what you're talking about, Paul, but I think, with the data, and we all have stories like this. I'm going to stick on the weather side, but I think we all have a shared story of the value of data, right? If we talk about the impacts of the data, right? So we talk about weather and climate data. A quarter of the GDP is driven by accurate weather and climate data, right? So that it goes across public sector, private sector, insurance, aviation, right? How much money folks, taxpayer saves, per evacuated, unevacuated square mile, right? There are a lot of impacts that are in the data that we have now, right? So how do we make that data more available? How do we use it not just between our agencies, right, which is important, right? We're all kind of interdependent. We have overlapping, data missions, I guess is not the right way to say it, but we all share data as a government, right? And we want to lower barriers to that. But there's also on the research side, right? How do we open up this data to make it useful across industry, academia, make it useful to the wider community, right? So we have a couple of programs in NOAA to kind of open the data up. We have the big data program, which has now changed its name to the NOAA Open Dissemination Program. But again, it's how do you get data to an available state and a usable state, right? And there's lots of other little technical details in there. Do we have the right formats? Do we have to do conversions? How does it make not just available but accessible, right? And how do you broaden that out to the bigger community so that you can add you're furthering the impact of that data, making it more useful to everybody.
Kurt, is there anything you would like to share on the topic of data sharing?
I'm sure. I mean, I guess it's interesting. So like, there's so many of these things, and I think, forums like this are actually quite helpful and where, ThunderCat as a company sits in there and, having the conversations with the folks from the DoD and NOAA and the DOE. And I think the idea of moving towards this, as I've mentioned before, on the data-centric side, from the cultural side, how we're taking all of these different pieces and parts, and there was points where we could merge that stuff and work that stuff together with on the DOE side from the summits and the auroras and of the world. And a lot of that stuff's being pulled back, and you can use it in other technologies with smaller clusters now, and even smaller single machines in some cases, in order to get some of that insight and then feed it all back in. So I think that it's quite exciting, where things are going in terms of this. And I'm really looking forward specifically to conferences like supercomputing this year in November, where, hopefully a lot of these same folks are going to be there, and we can have deeper conversations and move forward.
Absolutely. Wow. Thank you all so much for joining us today for this excellent program. I think that we're out of time now, but it was so great to dive into these topics together. I know that this is something that you all could talk about all day. So hoping to hear more from you all in the future. And now we're going to turn it back over to Amy for closing remarks.